Hello everyone. In this class, I will explain variables like what is the variable, what is the purpose of variable, how to store the data using the variables. So, the variables which can be used to store the data. So, the data it might be either string or either boolean or either number data. So, any type of data you can store using the variable. But if you want to declare the variables in your JavaScript, we have three types of keywords in your JavaScript. The keywords are like where, let, and const keyword. With the help of these three keywords, we can declare the variable. So, for declaring the variable, we have some rules here. So, the first rule is the variable it should be start with either alphabets or either numbers. Sorry, it should not start with numbers. So, it should be small a to z or capital A to z or 0 to 9 or and it's allowing some special characters also, that is dollar symbol and underscore symbol. So on the second rule is it should not start with the variable name should not start with digits. Okay, remember this thing, should not start with digits. So I will tell you the simple example. I am taking one variable where a, B, C, 1, 2, 3 equal to 100. See, where is the first I am taking any variable. We can use either where or either let or either const keyword. So this is the keyword and this is the variable name. So ABC123. Here the variable name is start with the alphabets, right? So this is correct. It should not start with digits, but it can start with alphabets. So and this is the 100 is the value for this variable. So it is correct. And second, I am declaring where 1, 2, 3 ABC equal to 100. This is wrong. Why? Because here the variable name is start with 1, 2, 3. It is start with the digits, right? So this is wrong. So this is the syntax for variable. Now first of all I will explain what is the numbers in JavaScript. We have some numbers in JavaScript like decimal numbers, hexadecimal number, octal numbers, and binary numbers, and floating point or double number. These are the numbers in JavaScript. So for decimal number, the allowed digits for decimal number is 0 to 9. So what is the total count? 0 to 9 means 10, right? So the base value for this decimal number is 10. Now hexadecimal number. So the allowed digits for hexadecimal number are 0 to 15. So what is the count for this hexadecimal number? 0 to 15 means 16, right? So the base value for hexadecimal number is 16. Now octal number. So the allowed digits for octal number is 0 to 7. What is the count? 0 to 7 means 8, right? So the base value for octal number is 8. And then binary number. Binary number means it can be represent in zeros and ones only. So we can represent in zeros and ones. Here only two values, right? So the count for binary is 2. The base value for binary is 2. Then floating point number means where a equal to 10 point to something. So this before point is there. Now this is the integer part and this is the floating point part. This is the floating point number. So I will tell you we have some binary numbers for decimal numbers. So the decimal number means 0 I am taking. For 0, the binary number is 0, 0. For 1, the binary value for 1 is 0, 1. For 2, 1, 0. For 3, double 1. For 4, the binary value for 4 is 1, 0, 0. For 5, the binary value for 5 is 1, 0, 1. For 6, 1, 1, 0. For 7, 111. For 8, 1, 000. For 9, 1, 001. For 10, 1, 0, 1, 0. For 11, 1, 0, 1, 1. For 12, 1, 1, 0. For 13, 1, 1, 0. Sorry, 1, 1, 0, 1. For 14, 1, 1, 0. For 15, 1, 1, 1. So these are the binary values for these numbers. So for hexadecimal, so up to 9 okay. But from 10 onwards, the hexadecimal values is changed. See, the hexadecimal value for 10 is A. Okay. The hexadecimal value for 11 is B. The hexadecimal value for 12 is C. The hexadecimal value for 13 is D. And for 14 is E. And for 15 is F. So this A, B, C, D, E, F are the hexadecimal values for 10 to 15. And these zeros and ones is there, right? These are the binary values. Now I will explain the number conversion, like how to convert the octal to binary, hexa to binary, like that I will explain. See here, if you want to convert the decimal to binary, let me take one example. I am taking 100 here. This is the decimal number, right? Because the allowed digits are 0 to 9. Na? So 1 is the allowed number, 0 is the allowed number, 0 is the allowed number. So this is the decimal number. If you want to convert to this decimal to binary, so what is the base value of binary? 2, right? So that's why by using the LCM method, I am dividing this 100 by 2. So 100 divided by 2. So 250 is 100, right? So what is the remainder? 0. Then again divide 50 by 2. 225 is 50. The remainder is 0. Then again 25 by 2. 212 is 24. The remainder is 1. Then 2 6 is 12. The remainder is 0. 2 3 is 6. The remainder is 0. 2 1 is 2. The remainder is 1. If you want to represent the binary format, you have to take from bottom to up. So what is the bottom value? 1. 1 1 0 0 1 0 0. Don't take from top to bottom. We have to take bottom to top. This is the bottom to top approach. So 1 1 1 0 1 0 is your binary number. If you want to convert to decimal to from decimal to binary, we have to use LCM method. So the base value of 2 is 2, right? That's why I'm dividing this 100 with 2. Now binary to decimal. So if want to convert, this is the binary value, right? 1 0 1 1 0 1 1. So the first value is the most significant bit. The last value is the least significant bit. See, the LSB means least significant bit. This is the least significant bit. So the position of this LSB is 0. So we have to calculate the positions from right to left. So the position of this one is 0. So positions is starting from 0 onwards. Then the next position is 1, then 2, 3, 4, 5, 6, 7. So the MSB position is 7. So we have to multiply this. What is the LSB value? First value 1, right? So 1 into what is the base value of binary? 2, right? So 2 power, this 0 is the position of our LSB number. So what is the position of this LSB? 0, right? So 2 power 0. 2 power 0 means anything power 0 is 1, right? So 2 power 0, 1. 1 into 1, 1. Then again I am multiplying the second value. So what is the second value is 1. What is the position of this value? 1. So I am multiplying this 1 into the base value of binary is 2, right? So 2 power, the position of this 2 is 1. Sorry, the position of this 1 is 1. So 2 power 1, 2. Then again the third value is 0. 0 into what is the base value of binary? 2. 2 power, the position of this 0 is 2, right? So that's why 2 square. 2 square nothing but 4. 4 into 0, 0. So you can do remaining things same like this. And what is the MSB value? 1, right? So 1 into what is the last position of this one? 7, right? This is the position number 7. So I am multiplying this value, this binary number, 2 power, the position of this MSB value is 7, 2 power 7, 128. Then after that we have to add all these numbers. So the final result is 155. This is your decimal number. So if you want to convert binary to decimal, then we can use this method. Now I will explain octal to binary. See, if you know the binary numbers, right? If you know binary numbers, we can directly do. See, 5 means 101, 6 means 110. So, but remember one thing: if you want to declare the octal format, we have to use 3 positions. But if you have to declare the hexadecimal format, we have to use 4 positions. See, here I am converting the octal to binary, right? So here 5, we are converting to binary from octal. That's why I am taking 3 positions for this number. 5 means 101, 6 means 110. Suppose it is, if it is hexadecimal, then we have to take 4 positions, which means we have to use 0 before 101. Okay, this is the conversion of octal to binary. Now octal to decimal. I am taking one octal number 140. So the allowed digits for octal number is 0 to 7, right? So 1 is the allowed digit and 4 is the allowed digit and 0 is the allowed digit. So now I am converting this octal to decimal. So what is the base value of octal? 8, right? See, 0 is the LSB and 1 is the MSB here. LSB means least significant bit. I am multiplying this LSB 0 into, then what is the base value of octal? 8. 8 power, what is the position of this 0? 0. So 8 power 0 means 0. 8 power 0 means, what is the value of 8 power 0? 1, right? So 1 into 0, 0. Now the second value is 4. 4 into the base value of octal is 8. 8 power, the position of this 4 is 1. So 8 4 is 32. Now 1 into 8 power 2. The position of this 1 is 2, right? That's why I am taking the power of 2. This is 64. Then we have to add these 3 numbers. The final result is 96. This is your decimal number. Now I'm taking here, I will explain one more example, hexa to decimal. See, the second row is the decimal numbers and the first row is the hexadecimal number. So up to 9 is same for both hexa and decimal number, but the 10 is the hexadecimal value for 10 is A, for 11 B, 12 means C, 13 means D, 14 means C, 15 means F. So here I am taking one example 2C9B. I need to convert into decimal format. So the what is the LSB value? B. So B means, what is the value for B? B means 11, right? In decimal. So 11 into the base value of hexa is 16. 16 power, the position of this B is 0, right? So 16 power 0 is value 1. 1 into 11, 11. Now the second value is 19. In the second position, we are having 9 value. 9 into 16 power, the position for 9 is 1, right? So 16 power 1, 144. Now C means 12. So 12 into 16 power, the position for this C is 2, right? 16 power 2. Now, and the last MSB value is 2. 2 into 16 power, the position of this value is 3. So finally, we need to add all numbers. The final result is 11,419. This is our decimal format. Now, octal to decimal I explained, right? See, now I'm taking one more example, hexa to binary. So if you want to convert to hexa to binary, first step is you need to convert from hexa to decimal. Then you need to convert to binary. So in the first step, here I am taking one hexadecimal number 6a. So a means 10, right? So 10 into, this is the LSB value, right? 10 into what is the base value of hexa? 16. 16 power, the position of this a is 0, right? 16 power 0 means 1. 1 into 10, 10. Now the second position, the value is 6. 6 into 16 power, the position is 1. 16 into 96. So this is the 96 plus 10, 106. This is the decimal number. Now we need to convert this decimal number to binary. I already told you, right? If you want to convert to decimal to binary, you can use the LCM method, and you can use the bottom to top approach. So 110 1010 is your binary number. Here I am taking simple example. Here also we can convert the hexa to the binary. If you know the binary values, then we can directly 5 means 101, right? But it is hexadecimal, right? That's why don't take 3 positions. For octal we need to take 3 positions, but this is hexadecimal, right? That's why here we need to take 4 positions. And then F means double one double one. So this is our number systems. Now I will explain simple JavaScript program using the variables. I am taking one file, variables.js. See, I am taking one variable where decimal number. I am taking one decimal number 10. I am consoling this decimal number. Okay. Let me take a like. Now the second variable I am taking one floating point number 10.21 like that. I am consoling console.log of b. Don't use duplicate variables. Now where c equal to, I am taking one octal value. So if you want to declare octal value, you prefix with 0 0 o 0 o 1 2 3. Console.log of c. Now I will take, here I am taking one hexadecimal value. If you want to take hexadecimal value, it should be prefixed with 0x 1 2 a b. Now I am consoling this console.log of this decimal number. Now finally I am taking one binary number. So let me take one variable for binary number where e equal to, if you want to define some binary number, it should be prefixed with 0b. So binary numbers are zeros and ones, right? So 1100 I am taking. So now I am consoling this binary number console.log of e. See, I am saving this file. See, node variables.js. So if you want to execute your JavaScript program, you have to use command like node with file name. See, this 0b11 is not defined. So this is the value. Okay, 0b. Here I used O instead of 0. That's why error came. See, if you want to declare the binary variable, we need to use 0b. Now I'm saving this file and I'm executing this one. See, the first console value is decimal number is printed. Now floating number also printed. Now the third value is 0 O means octal number, right? So I'm getting this equivalent decimal number of for this octal number 83. Now 0x12ab, this is the hexadecimal number. The equivalent decimal number is 4779. And the last value is binary value, right? 1100 means 12 now. So the binary value, so the decimal, the equivalent decimal value is 12. Okay. Now I'm taking one boolean flag equal to true. I'm taking. Now I'm consoling this flag. Console.log of flag. Now I'm taking. I'm consoling console.log of true plus true. So in JavaScript, true means 1, false means 0, right? So console.log of true minus false. And one more thing, console.log of, I'm taking one string here, plus true. Again, I'm taking one more example, console.log of 1 plus true. See, here true means 1, true means 1, 1 plus 1, 2. So the result is 2. Here true minus false, true means 1, 1 minus 0, 1. Here the 1 is double quotes, right? This is not a number, this is string. So the string plus true. So this is concatenator, right? So 1 2 will get a 1 true. And last is 1 plus true, right? So 1 is the number. So 1 plus true is 1. True means 1, right? So you will get a 2. Let me execute this one. See, I'm getting this flag is true. Now true plus true 2. Now true minus false 1. Now string plus true is, it is concatenated. Now 1 plus true is 2. Okay, if you want to console based on some conditions, so you can use the ternary operator. So in upcoming videos I will tell you the what are the operators available in JavaScript, but just understand the concept here, how to render this console thing by using some based on conditions. I am taking one variable 100. Let me take different variable. I'm taking variable 10 where x equal 10. If x value is equal to 10, then I need to console.log of yes. If x value is not equal to 10, then I need to console no. See, here the x value is 10, right? So here I am checking the condition. If x value is 10, yeah, correct. So that's why the first part is executing. If it is false, then the second part is executed. I'm saving this file. I will get the value as yes. Why? Because here the condition is satisfied, right? So this is called conditionally rendering. So we'll get here we are getting the yes. Now here I am taking different values 20. Now see, I'm checking the condition. If x value is 10, no, right? So the second part is executed. So now I will get no. Why? Because the condition is false. So this is called conditionally rendering. Okay. In next class, I will discuss about how to store the variables using the strings and all, and what are the difference between